Alright, the purpose of this video is to review the main types of polynomial factoring. Now when you're factoring any polynomial, the first thing you look for is greatest common factor. It doesn't matter what other methods might be involved, that's the first thing you consider. Is there something that divides into both of the terms or all of the terms? In this case 2, x squared does, and y cubed. So there's my first set of factors. And the second factor is this divided into each of those. So what do I need to multiply my greatest common factor by to get this? I need 2, and for the second term I need plus 3x y to the 7th. Alright, once you're finished greatest common factoring, then there are some other types of factoring to look at. If you have two terms, the only type of factoring that you're familiar with at this point is difference of squares. And remember, that's where you have a subtraction sign in the middle and two perfect squares. And if you have that, then you'll remember that the pattern is the square root of the first, the square root of the last, one term gets a plus, one term gets a minus, and you are done. Alright, if you're confronted with three terms, then there are three types of factoring that might be involved. The first one is kind of a special case, and it's probably the hardest one to identify, but let's just go through it just to review it. Perfect trinomial square, and that's the idea that does the trinomial factor into something squared, like so? Well, it will do that if the first and the last terms in the trinomial are perfect squares. Okay, and the square roots of those would be 2x and 3. And if the product of these two doubled gives you the middle term. So 2x times 3 is 6, doubled is 12. So if in my expansion I had 2x here, 3 here, and a minus, there's my negative 6 coming about. That double would give me negative 12. It does work as a perfect trinomial square. Alright, if it's not a perfect trinomial square, then one of two other types of factoring may exist. The first type is when you have a trinomial with a leading coefficient of 1. Okay, now you'll see here that this is definitely not a perfect trinomial square because even though x squared is a perfect square, 6 is not. Alright? So in this method, the polynomial may break down to two binomials multiplied together, two binomials that are not identical. And we know that the first term would be x and an x. The last term has to multiply to give me 6. And the same two numbers have to add to give me negative 7. So you have to think about whether these numbers exist or not, and they may or may not. If they do, it's factorable. If they do not, it's not factorable. Two numbers that multiply to 6 add to negative 7, negative 6 and negative 1. And so you've got x minus 6 and x minus 1. Alright, and finally you have trinomials in which the leading coefficient is not 1. This is obviously not a perfect trinomial square because the front and the back are not perfect squares. Okay, and so for this type of factoring, what I suggest is this vertical method where you think of what are the possibilities for the front. What multiplies to 2x squared? Well, 2x and x might work. What two numbers multiply to the back? Could be 6 and 1, 1 and 6, 2 and 3, or 3 and 2. And what I need to do is I need to test each of these possibilities in that spot. So if I just test 6 and 1, this is 6x, this is 2x. Remember that these two cross products have to add or subtract to give me this. Well, 6x and 2x doesn't do that, so that's not it. Let's try 1 and 6. The cross product is 12, the cross product is 1. That does not add or subtract to negative 1. Let's try 2 and 3. Cross product is 6, cross product is 2. That does not add or subtract to negative 1. And so our last possibility is 3 and 2. Cross product is 4, cross product is 3. 4 and 3 subtract to negative 1 if I put a negative on the 2, so that I have negative 4x and 3x. Okay? And so my factored form is 2x plus 3, x minus 2. Alright, let's put this all together by looking at these 4 examples. So, when we start factoring any polynomial, we first of all want to think about, is there a greatest common factor? So in our first question, there's nothing that divides into both of these, so there's no GCF. We now have 2 terms. If we're following our list from the previous page, the only type of factoring we know how to deal with is having a subtraction in the middle and 2 perfect squares. Well, that's exactly what I have. Both the first and the last terms are perfect squares. So I have AB as the first term in each binomial, 10R at the end, 1 gets a plus, 1 gets a minus. My next question is a trinomial. So if I go down my list of 3 trinomial techniques, the first one to consider is it a perfect trinomial square? Well, looks like it might be, because the first and the last terms are perfect squares. Those are the square roots. And the question is, do these 2 terms doubled give me this? Yes, they do. Therefore, it factors to 3x plus 8 squared. Remember, you can always check your answers by multiplying the answer out to see if you get what you began with. Number 3. Again, let's think about greatest common factor. There is no greatest common factor here. So moving on, we have 2 terms with a subtraction in between. So we have a difference of squares because both of the terms are perfect squares. So that breaks down to x squared at the front. 1 gets a minus, 1 gets a plus, minus 4 plus 4. Alright, now in this question, if you look at each of these binomials, the first one is a difference of squares again. It's 2 perfect squares with a subtraction sign. So this term is going to break down into 2 parts, x minus 2, x plus 2. We have 2 terms for the second binomial, but a sum of squares does not break down, so we leave that the way it is. So there's our factored form, 3 factors that would give us the original expression. Our last example, again, start at the top of the list. Greatest common factor is 2x, which would leave us with x squared plus 7x minus 60. Okay, so we have 2 sets of factors. Now, we have sitting here a trinomial in which the leading coefficient is 1. So this trinomial has the potential to break down into 2 binomials. It may or may not, but we have to check it out. The pattern for that type of factoring is looking for 2 numbers that multiply to negative 60, the same 2 numbers that add or subtract to 7. And if I think about that for a moment, I find that 12 and 5 will work as long as the negative is on the 5. And so my factored form is x plus 12, x minus 5 times 2x.